for the intro, and also thank you very much for all of you attending today. I appreciate that. We all do. You know, today we are going to be covering a subject, as Susan mentioned, conversions that help cut costs, which, you know, when starting with fuel conversions may seem naturally intuitive initially. But when you delve into the subject with some thoughtful consideration, certain excellent opportunities for converting may not come to mind, or ramifications in adapting that fuel to the boiler were not considered. Or, on the other hand, the directional thinking was sound, but the investment is wrong because the boiler wasn't worth investing in the first place. In other words, the juice just is not worth the squeeze. So with that as a way of kind of generally framing today's program, here's what we'll be covering today. What has been driving fuel considerations and fuel conversions? We'll talk about that a little bit. And then determining the investment viability. Technical considerations for the popular fuel conversions. I want to get into the pros and cons for these. Then at that particular time when that boiler is down, is it a good time to plan ahead, and does it make sense to maybe do some other options at the same time while it's down? And then as normal, we will give you a summary of at least what we feel are the germane or important points from this discussion today. And then as Susan said, we'll have a Q&A. These are questions that you text in, and we will answer as many as we can audibly. Now, when considering what is motivating people to look at either adding a fuel, converting from one fuel to another, or just upgrading their existing equipment to burn a fuel more efficiently and reliably, the reasons are varied. But for the most part, the main driver is economics, or said another way, saving on that fuel spend. Unfortunately, if this is the only reason and one is uninformed on the other factors or the implications which might impact this fuel choice consideration, the expected savings can quickly become unexpected costs, but I'll address that in a bit. But before I do, let's look at the general possibilities for fuel cost reduction and where they may occur. You know, first there's a possibility a lower cost fuel becomes available which was not present before, and this happens more than you would think. For instance, natural gas becomes available, and I'm currently burning either number 2 oil or propane. Now these two fuels, which at least when I compare cost BTU to BTU, they're more expensive. Then there's the possibility our manufacturing process may be producing combustible liquid byproducts, which we're currently paying to be disposed of. Or in the case of, let's say, waste gases, we're just flaring off. Or maybe we're burning a fuel which, when we look at the costs for burning it and handling it, can be substantially reduced if we change to a simpler fuel to burn. And lastly, if we have the capability to burn another fuel, it could lead to some very attractive rebates from either the utilities or other fuel manufacturers or both. Now, the other major driver for fuel conversions is reliability, especially when we're involved with critical processes. And I think a good example would be pharmaceuticals. You know, in many cases, a stop in the process can cost thousands of dollars, not an hour, but a minute. So having an alternate fuel backup can seriously help in making or breaking a financial month or a financial year. The other major driver is local code changes, which normally equates to upgrades of existing equipment, but if it has to do with the EPA, the Environmental Protection Agency, it may indeed involve a fuel change in order to more easily and economically meet the required standards. For instance, changing from, let's say, burning oil to natural gas or propane will certainly positively impact NOx, nitrogen oxide regulation limits. Then, of course, we have those situations where our fuel burning system is it's outdated, it's inefficient, and it's unreliable. So it's time for a change or a major upgrade to new burner equipment and maybe adding that change in fuel at the same time. And finally, we have the driver, which has gained considerable legs over the past several years, and that's the environmental push. People across all walks of life have become so much more aware and educated about our environment, how finite our resources are, and how susceptible we are to dangerous pollutants, which can negatively impact us for generations. And as a result, we have many customers switching to cleaner burning fuels such as natural gas, while including NOx lowering capabilities to reduce the photochemical smog problem. Now, this, along with the burning of biofuels, which not only may save on the fuel spend while reducing pollution, but these fuels are also sustainable, all of which appeals to those embracing and highly prioritizing the environmental impact and the negatives associated with the burning of finite fuels with heavy concentrations of carbon. Therefore, when we look at the fuels associated with conversions, the choices are many, as found in these general categories on the screen now. So what I'd like to do is take a closer look at them while briefly evaluating the pros and cons of each, and I think we'll start with natural gas. Natural gas, as you all know, has been around for decades, and quite frankly, as you know too, is the go-to fuel in many of our operations today. And that's because of its benefits, starting with availability and the ease of handling. It's easily piped to the burner, and burning this fuel is pretty straightforward, and it's uncomplicated too. It also carries a very competitive price, especially since we in the United States have been tapping into many of the shale reserves that have been discovered over, the past 10 years, and creating, albeit fluctuating, oversupplies. Now, the other thing with natural gas, and this appeals to the environmentalists for sure, is its low carbon content, which lowers the amount of carbon dioxide released to the atmosphere, which of course, as you all know, is a precipitant of global warming, while also being clean burning, normally zero particulate. And then another thing that appeals to the EPA regulators and the environmentalists is the fact that natural gas contains zero fuel-bound nitrogen. This just innately reduces NOx levels when compared to the burning of other fuels such as light and heavy oil. And finally, natural gas has acceptable combustion efficiency, but that leads to its only con. It has a great deal of hydrogen in it, and when combined with the combustion air, forms moisture that robs the burner of BTUs as it flashes into steam, and that of course forms, or that's now the latent energy, which when it condenses in the atmosphere, results in a net loss of 1 to 2% when compared to the burning of other higher carbon-based fuels. Okay, what about the pros and cons for propane? Well, to begin with, and just like natural gas, it's readily available. It's fairly easy to handle and burn, and I say fairly easy to handle because it will require a vaporizer for burning it straight and a fuel-air mixer if it is to be reduced to the approximate BTU content of natural gas, which is about 1,000 BTUs per cubic foot, and then sent through the natural gas firing head in the boiler. In other words, use the same train. And by the way, propane is about 2,600 BTU per cubic foot. And like natural gas, it's clean burning, and because of its higher carbon ratio when compared to natural gas, it has a higher combustion efficiency capability. Now, on the negative side, propane requires on-site storage and the maintenance issues connected with that, along with assuring that the supplies remain adequate. Now, as mentioned, it has a higher carbon footprint, therefore more CO2 generation, which from an efficiency standpoint is really good, but not from an environmental perspective. Now, it's also more costly per cubic foot than natural gas, and if the propane is to be burned in the boiler without mixing with air to make it closer to natural gas, it requires a burner modification because of differences in the BTU content, the specific gravity, and so on. And that burner modification often affects the burner housing containing the orifices through which the gas emanates. If this particular, or I should say in this particular example, we have what is referred to as a dual housing, incorporating separate sets of orifices for natural gas and propane. They're separately compartmentalized within the same steel unit. Now, as far as burning standard oils, let's talk about number 2, number 4, and number 6. As far as they are concerned, and even though number 4 and number 6 have been pretty much regulated out in much of the country because of the clean air restrictions, it's still used. They're still used, but certainly not as commonly as number 2 oil. But I think it's good to briefly discuss it anyway. So when looking at the pros for both heavy and light oils, the first thing that you have to say is they are both readily available. They're also delivering high combustion efficiencies, part of which is no moisture losses, making them an excellent primary or alternate fuel choice. Now, when considering the cons for heavy oil, handling is an issue, including the need for heating it to the proper viscosity, and I'm talking 200 Seybold universal seconds, and the need for atomizing it with compressed air in order for it to exit the nozzle with sufficient misting and volatility for proper combustion. The storage tank housed somewhere in the boiler room, it has to be heated in order for the oil to be pumped to the burner and then back to the tank when that burner is modulating and not as much oil is being burned. And then because of the nature of the fuel having a high carbon and ash content, the boiler needs to be cleaned more frequently. And speaking of the constituents in the fuel, there are other chemical elements such as sulfur and nitrogen which need to be stringently controlled in order to pass specific EPA regulations in various parts of the country. And all of this just drives up operating costs when burning the heavy fuel oils. Now, as far as the number 2 oil is concerned, they're pretty minimum as far as the cons are concerned compared to burning heavy oil. But we still have to contend with the storage tank, though it's unheated, and pumping to and from the tank. Cleaning is probably going to be more frequent than when burning natural gas, and as a result, total operating costs, including the price of this fuel, are going to elevate. Now, I might also add that an air compressor may be part of some burner packages to optimize the fuel similar to heavy oil, I should say to atomize the fuel similar to heavy oil, but many manufacturers also use mechanical or pressure atomizing nozzles, thus not requiring a compressor in that particular application. Okay, what about biofuels? Well, you know, if we look at this term, it is often used collectively and interchangeably, but if we break it down into the fuels within the heading, we find it consists of solids, of gases, and of course we have liquids. And what they all have in common is they are all, as I mentioned before, sustainable because they're renewable. For instance, we have solids such as corn, we have sugar cane and grasses to make fuels such as ethanol. You're familiar with that. We have wood waste, which can be burned in boilers. And then we have various processing operations generating waste oils. We also have stores and restaurants generating fats. And they all have BTU value, and they can all possibly be burned in a boiler. You know, we also have plenty of landfill sites and sewage treatment facilities that are producing primarily methane gas through what we call a microbiological degradation process. Now, this can be burned in boilers as a primary or alternate fuel based on the quantity and the ready availability of the supply. So, you know, for our discussion today, when talking about biofuels, and because of the time constraints, I'm going to limit it to landfill and digester gas, both very similar, And then, of course, we'll talk about waste liquids. And we'll start with landfill and digester gas pros and cons. Looking at the pros, you see this fuel is very inexpensive and maybe even free if the generating process is in the plant, and that's where the boilers are located. And next, it's a sustainable and renewable fuel, and it's environmentally friendly, having a very small carbon footprint. Now, as for the cons, this fuel has a very low BTU value, probably about 500 BTU per cubic foot versus natural gas about 1,000. So you need to burn more of it to meet the boiler's capacity. Now, it's also delivered at a very low pressure, meaning the gas train has to be larger to reduce pressure drops, or an expensive gas pressure booster needs to be added. And it can be very corrosive with large amounts of sulfur contained within the gas. Now, this means not only does the gas train need to be larger or the pressure boosted, but it also needs to be constructed of stainless steel, including the valve parts that would be coming in contact with this gas. And then we have the transportation issue. If you are not generating the fuel yourself on site, you need to be next door to the supply to be able to use it. And then finally, the supply can often be unpredictable, meaning this is most often burned as an alternate fuel when the supply is sufficient. This means if your primary fuel is, let's say, natural gas, you'll have two separate gas trains possibly coming into the same housing, that dual canister housing that I showed you before. Okay, let's now take a look at waste oils and the pros and cons for using these fuels, which might be coming from waste oil recovery services, food services, meat processing, and maybe some chemical or pharmaceutical manufacturers. As far as the pros are concerned, they can be inexpensive to buy, especially if generated in the same plant, in which case the cost is zero. But even if not, the generator of these fats has to pay disposal costs. So the price to the user may be very low, possibly just having to pick it up. Secondly, normally these waste fuels can have significant BTU value and can burn at a high combustion efficiency. And of course, they're sustainable, which leads to some environmental pluses, especially when they are being gainfully employed and not dumped into the sewer, into fields or rivers. Now, as far as the cons are concerned, these fuels need to be analyzed by the manufacturer of the burner equipment to make sure they can be burned without causing excessive deterioration of mechanical components, that they provide the benefit expected, and do not pose significant safety issues. Now, once that hurdle is crossed, the system has to be specifically engineered to assure proper combustion and maximum efficiency. Now, this, by the way, might involve handling the fuel similar to what I previously outlined for heavy oils, such as preheating, atomizing, and so on. And then finally, there may be some air permitting issues to be addressed based on the constituents found in the fuel analysis. All right, so we've covered the popular fuels being considered for conversion, including their pros and cons. So let's say we decide to further the process. What's the next step? Well, you know, if it were me, I'd make sure the boiler I was investing in was in decent shape. You know, why invest in a dead horse, so to speak? Maybe it's time to make some upgrades with a boiler that still has life, or maybe it's time to think about another boiler, either a new one or a used one. In other words, take a hard look at the boiler and its key components to assure that they are sound before investing in the fuel change. And I'd start with the burner. Number one, is it in good shape, and does it provide good combustion efficiency throughout its turn down? And don't judge the book by the cover. These burners look like they've seen better days, but they actually perform very well. Or maybe it's time to replace that burner, adding the fuel you intended to convert to. But in either case, keeping the burner you have or buying a new one, they have to be capable of burning the new fuel efficiently and reliably and safely. Then it's on to the pressure vessel, making sure it isn't corroded or leaking or heavily scaled. Now, these can all be fixed, but the investment may just not be worth it. And speaking of fixing what is wrong, fixing or replacing refractory insulation is a no-brainer. If it is compromised, as you see some examples of here, fix it as soon as possible, or efficient energy production will be sacrificed, along with serious mechanical and structural failures with the boiler following soon after. Okay, we've decided the boiler is worth the investment. What does the conversion supplier normally provide with these fuel conversions? And again, because of the limitation on time with these webinars, I'm only going to cover adding a natural gas conversion to a straight number 2 oil-fired boiler, and then we'll do just the opposite, go through a heavy oil to straight gas-fired boiler, because the heavy oil conversion also comes close to what we might find when adding a waste liquid fuel firing capability. So overall, this should give you a good idea of what the supplier provides, regardless of the fuel being added or converted to. So, starting with the natural gas conversion. The supplier has already had an experienced field engineer at the site to analyze the logistics of the room, including the existing utilities, as well as the details about the boiler, the existing burner configuration, along with its conversion adaptability, and then special note is given to the furnace into which the burner will be firing. Now, this information is then sent to the supplier's engineering department, who analyze the existing conditions that have been provided by the field, that field engineer, and then determine what will be required to match the need and the existing boiler room conditions. Now, after the review is complete, a tailored engineered solution is determined and then documented in a formal proposal for the customer, including all the components required for the conversion and also including the labor to install it. Now, in a gas conversion, what is normally proposed and supplied is a new burner drawer. An example is, as you can see in the upper right-hand corner of the screen now, and that's for accommodating the main natural gas supply and including the gas pilot. This drawer would also then have provisions for accommodating the existing number 2 oil. Next, we will need a new burner housing in which the drawer fits, and it will include the entrance port for the main gas and the gas burner ring as indicated here. We then have the gas train components as displayed on the screen, including all the required piping, valves, switches, and the complete pilot train. The fuel-air ratio control linkages, as seen in the lower left corner of the screen, are also included, and you may have a choice to go with the linkage system or the parallel positioning system that uses servo motors with a central controller, and that's also shown here, as you can see. You'll probably also find control components to be wired in and mounted for easy fuel selection, a switch, fuel selector switch. The package is then completed by supplying the required fireside gaskets, a wiring diagram, and of course a new nameplate that now will be including the added fuel usage. Now, the other thing that I wanted to bring to your attention today is the new unitized gas trains that have come on the market. On the screen, you see the old standard gas train with large valves and fittings, including the vent connection between the 2 motorized valves, and not shown is the gas pressure regulator that would be mounted upstream. compare this to this unitized gas train module, complete with motorized valves providing a much lower pressure drop, meaning smaller diameter piping can be used, which saves not only on the valve components, but the piping cost as well. And the other nice features with these trains is, besides being fully assembled, they incorporate an integrated gas pressure regulator, which experiences less pressure droop when the valves initially open, which positively impact flame stability. All right, let's turn our attention to the liquid side. And I'm going to detail a number 6 oil firing conversion, as this, as I mentioned, comes very close to many waste liquid fuel burning applications, such as waste oils and waste fats. Now, with this type of conversion or addition, most everything is provided by the supplier, similar to the gas conversion, and starts with a new burner drawer, including the provision for the gas pilot or oil pilot, though I must say that gas is the preferred option and found to be most reliable. It will also include the complete gas or oil pilot train, the oil gun assembly, including the integrated oil supply and primary airline for atomizing the fuel, the fuel oil control and metering system, and of course, we will need an oil pumping system, which is included, along with an air compressor module if plant air is not available for fuel atomizing. And then, because this fuel has a heavy viscosity, an oil heater is required. And similar to the gas conversion, fuel-air ratio control will also be included, and as before, it can be either linkage-driven or motorized control. And again, as with the gas conversion, the package is rounded out with the electric fuel oil selector switch or fuel selector switch, fireside gaskets, wiring diagram, and a new nameplate. And once the total package or kit arrives, you know, it's very important to be installed by a qualified technician who truly understands, what needs to be done and can do it with a minimal amount of time and disruption for the customer. Now, this normally involves a close tie with the supplier and the resources that he or she can provide if necessary. Now, over the years, at least in my experience, customers have taken this time while converting from one fuel to another or adding a fuel firing capability to take stock to see if now isn't a good time to make some other upgrades. As a matter of fact, there are cases where a customer has multiple plants and one has a boiler which has been decommissioned and it's only being used to salvage parts. And it so happens another of its facilities is looking to add natural gas. Now, in this case, the gas train is taken off the decommissioned boiler and sent to the other facility, saving the cost of the gas train. However, it will need to be piped properly, having a vent which goes up through the roof for safe discharge of the gas that's trapped or leaked between the two motorized valves, unless they add a ventless option, including a new burner management system and end switches on the gas valves, which are electrically tied into the new burner management system, which has been specifically designed to receive these signals and thereby proving when the valves are open or when they're closed. Now, this being the case, there's no need for a vent line because the only gas remaining will be the small amount trapped between the valves, which will pass to the burner once the cycle begins and the valves open. And speaking of burner management system updates, maybe now is the time to incorporate the new burner management control into a PLC-based platform, giving the operators and the facility staff numerous opportunities to tie in and monitor any number of functional operations. For instance, we've added digester gas firing capability and can now automatically switch to natural gas when the supply runs low, or the opportunity to add variable speed drive to the boiler's combustion air fan, saving significant amounts of electrical energy if the boiler modulates while tracking a varying load. The PLC platform can also accommodate and integrate oxygen trim, which compensates for uncontrollable and varying conditions such as ambient air temperature changes, barometric pressure changes, keeping the burner's fuel-air mix at the proper ratio for maintaining the optimum tuned efficiency and safety. And then there's the auto-powered stack damper, automatically closing when the boiler cycles off. This makes good economic sense because without it, and if the stack pulls, let's say, a draft of over 1 inch of water column, you have much cooler ambient air rushing over the heated surfaces of the boiler and cooling it down. And then when the boiler cycles back on again, this loss has to be made up by the burner in order for the saturation temperature to be reached in the boiler, and it's all dollars lost up the stack. And speaking of dollars lost, what about the stack losses? You know, I know I've talked about this before, but not in this context. Upgrading to a PLC-based platform can integrate this feed water preheating system into the total scheme of energy-saving options. Where did I leave off here? All right, so what I'm saying here is you have this color touch screen, and in this case, you can readily see the operating pressure of the boiler versus the set point. You can see the incoming feed water temperature, the temperature into and out of the economizer if you have one, the variable frequency drive output if you have that, the stock oxygen reading along with the operating efficiency. And you know, the more you know, the better you can control. And, you know, I mentioned operating pressure and temperature versus set point. These boilers, as you can see on the screen, can get pretty high. I mean, 10 to 12, 15 feet to get to the pressure or temperature controls to reset them is not at all uncommon. So this means that you have people on ladders, and people being people and getting distracted, they can fall, and that can be serious. Whereas with these PLC-based controls, all the pressure temperature control adjustments are performed at floor level. And with the touch of the screen, couldn't be simpler and certainly couldn't be safer. And finally, these systems can provide interconnectivity of everything in the boiler room, not just the boiler and its accessories, as I mentioned, but all the accessories in the boiler room, including the water treatment equipment and the boiler feed, such as the vented receiver or the deaerator. And you know, as I've said so many times in the past with these webinars, knowledge is power. The more you know about a complete boiler room system and how it's performing minute by minute, the more you can positively impact efficiency, reliability, and safety. It just makes a whole lot of sense, not only logically, but in the financial sense too, and in that case, I would spell it C-E-N-T-S. And when I talk about knowledge being power, it starts, of course, with training and education for sure, but then equally important, you need a strong communication system to transfer the information to the people who can make a difference. And that's exactly what these PLC-based platforms allow us to do through various communication tools, be it a handheld smartphone as you see here, a laptop, an iPad, or a desktop. The integration with these PLC-based platforms is virtually limitless, as it allows us to connect to the company's far-reaching SCADA systems, for instance, for the monitoring and control of the entire industrial operation or complex. Pretty mind-boggling. What I've seen over the last 50 years as I note the strides in this industry, which was so stodgy for so many years, evolving dramatically over the last 20 years, and it has been primarily through the adaptation of the advanced industrial control technologies and incorporating these, I should say, on our boilers and our boiler accessories, making them so much more efficient, reliable, and safe. Pretty amazing. Okay, I'm sorry about that interruption a minute or so ago. I don't know exactly what happened. Amazing technology, as I was just saying, right? Anyway, here's some of the takeaways. Fuel conversions are normally driven by economics, reliability, code changes, outdated equipment, and environmental issues, but other considerations need to be reviewed before that step is taken. All the fuel considerations have pros and cons associated with them, and I think I went through the major ones. The biofuels can be divided into solids, gases, and liquids. Before investing in a fuel conversion, make sure the boiler is sound, meaning the burner and the pressure vessel. A good fuel conversion retrofit requires an experienced field representative and strong supplier with engineering know-how and experience. Fuel conversions involve burner adaptations, including the fuel air handling, piping assemblies, refractory repairs, and controls. Gas trains have changed, now including unitized assemblies offering lower pressure drops and zero vent pipe purging of leak gas with a BMS, burner management system, and gas valve switch adds. Those are the proof of closure switches on the gas valves. Fuel conversion is normally a good time to assess going to a PLC-based control platform. These systems can be expanded to include any number of efficiency, reliability, and safety enhancements. And they can also be connected to the company's building management system, process system, other far reaches of the facility, or the company's broader campuses through a SCADA system. Okay, so it's